In June 2021, in the middle of a vast sea of sand in northwestern Australia, a helicopter spent the entire morning flying back and forth as if it were searching for something. Below there were no towns and no roads leading in, only rocky mountains, ravines, and one strangely green patch of land. Suddenly, the helicopter dipped and swayed, dropping to just 60 meters above the ground. The three people inside scanned every mountainside. Then they spotted one. Then an entire herd. By the end of the survey, they had confirmed the presence of 72 wild donkeys. That was remarkable because more than 500,000 donkeys had once been killed across the Kimberley. These animals had not survived simply by chance. For more than 20 years, a man named Chris Henggeler had deliberately kept them on this remote piece of land, not for money and not simply out of pity. He wanted to prove that the animal Australia had come to hate could actually be the only species capable of helping humans fight desertification. Then, after 24 years, a single patch of green appeared in the middle of the desert. But when the helicopter finally located the herd, everything began to spiral out of control. The Australian government made a decision that no one could have predicted. Before they were hunted on a massive scale in the 20th century, donkeys were once among the most valuable animals in the outback. They were first brought here in 1866 because they could handle the heat better than horses, eat shrubs that cattle ignored, and carry supplies across terrain too rough for wagons. But when motorized trucks arrived, donkeys suddenly became unnecessary. Many station owners could not bring themselves to shoot them, so they simply let them go. By the 1920s, wild donkey herds had begun to form, and Western Australia later officially classified them as pests. Today, Australia has the largest population of wild donkeys in the world. Environmental damage increases as their numbers grow. Herds of donkeys crowd around waterholes, trampling the banks into mud, clouding the water, and consuming grasses that native animals depend on. Their hooves also compact the soil, contribute to erosion, and even damage farm fences. They have become a direct source of pressure on the region's water, land, and wildlife. No predator was capable of keeping their numbers under control. Dingoes sometimes preyed on young donkeys, but adults were simply too large and dangerous. So what about humans? They shot donkeys around waterholes, set traps, and tried to herd them, but none of it worked. By 1978, the campaign had shifted to an industrial scale. Helicopters flew low over the landscape, while shooters chased donkey herds across rocky terrain, sometimes killing as many as 150 animals an hour. When the donkeys became too difficult to find, people fitted a radio collar to a live one and used it to track down the rest of the herd. In the end, the donkey population in the Kimberley was reduced by as much as 99%. But the story didn't end there. Once the government and the public had accepted wild donkeys as pests, almost no one stopped to ask, what had each individual animal actually done? But right here in this desert, a ranch owner named Chris Henggeler began seriously thinking about that question. Chris came to Australia in 1979 and later moved with his family to a remote place called Kachana, cut off from the outside world. There, in the East Kimberley, they established a ranch covering about 77,500 hectares. His was the only family living there, with 2 young children, and during the wet season they sometimes had to sleep under a tarp behind their vehicle. But what truly worried Chris was beneath their feet. The land was becoming increasingly bare, erosion was cutting deeper into the soil, and the ground was losing its ability to hold water. At first he thought reducing livestock numbers would be enough, but even after the herds were reduced, the land still failed to recover. That was when he began to question what had always seemed obvious. Chris decided to try something completely opposite to what the rest of Australia was doing, using grazing animals as a tool for managing the land. In 2002, while the rest of the Kimberley was still using helicopters to remove donkeys, Chris gathered roughly 110 to 250 of them and moved them onto some of the most degraded areas of Kachana. Chris believed that if they were properly controlled and rotated, large grazing animals could have a beneficial impact on the land instead of simply destroying it. But why did he choose donkeys? In fact, Chris had already tested this idea with cattle. The problem was that Kachana was not flat grassland. Much of it consisted of rocky slopes, thick spinifex, deep gullies, and high ground that cattle were reluctant to enter. Donkeys were different. They could climb into those areas and reach the very places where the land was most severely degraded. That ability made Chris see them in an entirely different way. But after 2 decades, When a helicopter discovered 72 donkeys living in an unusually green patch of land surrounded by desert, what decision did the authorities make about them? And why did that decision receive such overwhelming public support except from Chris Henggeler? But before that, we still need to understand exactly what these donkeys did to change the land. We said earlier that donkey hooves compact the soil. That is true in areas where a living surface layer still exists. But on land that is already dead, the hard crust on top is no longer something that needs to be protected. It is a sealed layer that needs to be broken. When donkey hooves crack that crust, water no longer simply runs across the surface. For the first time in years, it begins to soak into the soil below. Henggeler documented 4 effects. The donkey's hooves broke up the hardened soil. The donkeys dug for water in dry creek beds. Their manure carried seeds and nutrients into the soil, and then grasses and shrubs began returning in scattered patches. After heavy rains, temporary streams appeared in places where water had not flowed for years. The soil became darker. Young plants began growing in areas that had previously been completely bare. An international research team, including Dr. Ariane Wallach of the University of Technology, Sydney, and Dr. Erik Lundgren of Aarhus University, is now studying the donkey herd at Kachana and its effects on biodiversity, wildfire, and water systems. Breaking through the hard surface crust was only the first step. What the donkeys did next took researchers much longer to recognize because it was happening underground. What Kachana documented was not just a single mechanism, it was an entire chain, and none of the links worked in isolation. Donkey hooves broke up the hardened surface. Water soaked into the soil instead of running off. Grazing and trampling mixed dead plant material into the topsoil, creating a natural mulch that slowed evaporation and helped the ground retain moisture longer after rain. Donkey manure added nitrogen, phosphorus, potassium, and trace minerals to the nutrient-poor soil. Many seeds passed through the donkey's digestive systems almost completely intact. When they landed in nutrient-rich piles of manure, their germination rates were much higher than those of seeds lying on bare ground. Each pile of manure became a miniature nursery. The seeds were protected from birds, temperature swings, and wind. Seeds were also transported on the donkey's coats. They clung to the animal's hair and were carried distances that wind alone could not reach, increasing genetic exchange between isolated plant populations. Donkeys also reduced wildfire fuel in 2 ways. They ate dry vegetation that would otherwise build up as highly flammable fuel throughout the long dry season. At the same time, by improving soil moisture, they made the remaining vegetation less likely to ignite, creating breaks in the fuel layer that function like biological fire breaks. If you have ever followed the debates over wildfires in the western United States, then the question of which animals will consume flammable vegetation before it burns is not unique to Australia. None of these factors can restore degraded land on its own. Water without seeds is still just wet soil. Seeds without water will not germinate. Manure without ground cover still allows moisture to evaporate. They only begin to work when all of these things happen on the same piece of land during the same season. And behind this story is an even larger debate. In 2018, Erik Lundgren published a study in the journal Ecological, arguing that large animals introduced by humans may be restoring ecological functions that disappeared during the Pleistocene. Today, 8 introduced large animal species live in Australia. Researchers argue that conservation efforts sometimes target these animals for removal, even when their presence may be restoring functions that disappeared tens of thousands of years ago. Many conservation biologists disagree. The debate remains unresolved. In fact, Australian authorities had known about the Kachana donkey herd since 2018. They did not discover it for the first time during the 2021 helicopter survey. Chris had never tried to hide the animals either. On the contrary, Kachana, DPIRD, and the KRBA had already sat down together to find a way for the herd to remain without becoming a new threat to the Kimberley. The biggest question was how to make sure the donkeys would not leave Kachana, reproduce, and spread back into areas Australia had spent decades trying to bring under control. They discussed fencing, reducing the herd, domestication, relocation, and several other options. But in the end, none of the parties could agree on a management plan that everyone was willing to accept. What is surprising is that Chris was not opposed to killing donkeys. In the years that followed, Kachana itself removed excess males, animals that left the managed area, and individuals they believed needed to be culled. From 2018 to mid-2023, the property reported shooting around 125 donkeys. But that detail only makes the story more puzzling. If Chris was willing to kill more than 100 donkeys to keep the herd under control, why did he continue fighting so fiercely to protect the ones that remained? By 2021, the dispute was no longer confined to paperwork. A DPIRD helicopter flew more than 638 kilometers over Kachana, dropping low over mountain slopes, rocky plateaus, and deep gorges to count every donkey that could be seen. By the end of the survey, they had recorded 72 animals. Because the terrain was so difficult, DPIRD treated 72 as only the minimum number they could be certain was still alive. And they were not there to study what the donkeys had done for Kachana. On the 9th of August, 2021, a control notice was issued to the property. All 72 donkeys had to be destroyed. Chris disagreed. He argued that he had managed the herd for years, had actively shot animals that moved beyond the areas where he wanted them, and believed the remaining donkeys were still performing an important function on degraded land. Kachana appealed, and the confrontation continued from there. But then the story began to turn back against Chris. From 2021 to 2023, Kachana reported removing 98 donkeys. If that was true, the herd should have been shrinking. DPIRD decided to check again. In October 2023, the helicopter returned, this time flying much tighter survey lines, spaced only about 750 meters apart. The result made everything much harder to explain. 117 donkeys were still seen. In April 2024, the control notice was amended from 72 donkeys to 117. Kachana said the herd mainly operated within an area of about 26 square kilometers, but the data used by DPIRD suggested that donkeys in the Kimberley could have much larger average home ranges. A single animal could cross a 12-kilometer buffer zone in just one day, while Kachana's patrols might be separated by months. But if Chris still cannot prove that his donkey herd is being perfectly controlled, another question remains unanswered. Were the changes he saw at Kachana really just a coincidence? To find out, we have to leave the Kimberley and look at what donkeys are doing in other parts of the world. In 2021, in North America's Sonoran Desert, scientists placed cameras around dried-up stream beds. Across the cracked ground, they watched wild donkeys and horses use their hooves to dig into the sand, creating holes nearly 2 meters deep until groundwater began to seep to the surface. What was remarkable was that they did not keep this water for themselves. Birds, deer, and many other animals also came to drink. At times, when nearby natural pools had disappeared, these animal-dug wells became some of the few remaining sources of water. This does not prove that the donkeys at Kachana are saving the entire landscape, but it confirms something very important. Donkeys really can change the way water becomes available in a dry ecosystem. Then, thousands of kilometers away on Italy's Asinara Island, researchers discovered another role. They collected donkey manure and germinated the seeds that remained inside it. From those samples, hundreds of seedlings belonging to many different plant species emerged. A donkey eats plants in one place, travels several kilometers, and then leaves its manure somewhere else. At the same time, it carries seeds, nutrients, and organic matter to a new location. So what Chris observed at Kachana, that donkey manure could become small packets containing both seeds and nutrients, is not an entirely baseless idea. But the story becomes even more interesting in Death Valley. There, researchers found that mountain lions prey on young donkeys. In wetlands where predation pressure was high, donkey activity dropped by about 87%. There were fewer trails created by the animals and less bare ground caused by trampling, while plant cover was higher. The same species of donkey behaved very differently across the landscape simply because a powerful predator was present. That suggests the issue may not be as simple as whether donkeys are present or absent, but rather how many there are, where they are, and what keeps their behavior within limits. And perhaps the strangest case is found back in Australia. At Dalhousie Springs, when large animals such as donkeys and camels were removed from certain areas, vegetation around the water increased so dramatically that open water habitat shrank. A 2007 study recorded the disappearance of several fish populations within the spring system and suggested that ecosystems like these may sometimes require a certain level of disturbance to maintain their structure. This does not mean that removing donkeys was the only cause. Many management factors changed at the same time, but it does point to an uncomfortable lesson. Completely eliminating disturbance does not always make nature healthier. At this point, the story of Kachana begins to look different. Chris still has not proven that his donkeys are the reason the land became greener. The authorities also have practical reasons to worry that the animals could escape and begin reproducing again. But research outside Kachana shows that donkeys do more than simply graze and trample the ground. They can dig for water, transport seeds, create disturbance, and change the way other species use the landscape. After years of dispute, the battle between Kachana and the authorities finally reached its conclusion. The State Administrative Tribunal sided with DPIRD and upheld the order, requiring the removal of 117 donkeys. The tribunal's reasoning was fairly clear. Kachana had still not demonstrated that it could reliably control the herd's numbers, movements, and the risk of the animals spreading beyond the managed area. But what is important is that the tribunal did not conclude that Chris was wrong ecologically. The ruling did not answer whether the donkeys were helping the land retain water, reducing wildfire fuel, or supporting the recovery of vegetation. The issue before the tribunal was much simpler. These animals were legally classified as pests, and Kachana had to prove that it was controlling them tightly enough. The tribunal even acknowledged that what Chris was doing might be worth further research. Even so, the law still had to be enforced. Under the final order, at least 70 donkeys had to be removed by the 31st of August 2026, with the remainder removed by the 31st of August 2027. By the end of June 2026, Chris admitted that he had accepted the cull would have to begin. But there was one thing he still refused to do. He would not pull the trigger himself. Chris said he would not stop the people who came to carry out the order, but he also could not bring himself to shoot the animals he believed had helped bring this land back to life. An article in Australian Zoologist once summed up the donkey's journey in Australia in 4 words: from value to vermin. But the strange thing is, the animal itself never changed. The same hooves, the same body, the same instincts. What changed was the way humans saw it. Around the 1920s, when trucks made donkeys unnecessary, many transport workers could not bring themselves to shoot the animals that had once served them. So they opened the gates and let them go. That seemingly compassionate hesitation helped create the wild donkey herds that Australia would later spend decades trying to control. About 106 years later, Chris Henggeler found himself facing almost the same choice. He accepted the ruling that the herd had to be removed, but still refused to pull the trigger himself. This time, not because the animals had lost their value, but because he believed they were still doing important work on the land at Kachana. Perhaps that is the most thought-provoking part of this story. An animal can once be a tool, then become an invader, and under different circumstances become part of the solution. Nature is rarely as simple as good or bad. So what would you do? If you had to choose, would you keep Chris's donkeys or follow the order to remove them? Leave your answer in the comments. If you enjoy stories where nature forces us to rethink what we thought we already knew, subscribe to the channel, and in the next video, we'll travel to another place where a species once seen as a problem is making people ask the exact opposite question.